Hello everyone, welcome to our Egyptian online seminar group. First, keep your microphones off. Then, if you have any questions, you can ask our speaker during his presentation or after his presentation. I have great pleasure of welcoming Professor Miklos Vasarhelyi, Dr. Ting Sun, and Hanxin. Miklos Vasarhelyi is one of the top accounting thought leaders in the world. He is a professor of accounting information systems and serves as director of the Rutgers Accounting Research Center and continuous auditing, reporting lab. He is credited with developing the original continuous audit applications and is the leading researcher in this field at Rutgers Business School, and he has published a lot of articles in top-ranking journals. Dr. Ting Sun is an associate professor of accounting and information system at the School of Business, the College of New Jersey. She holds a Ph.D. in accounting information system from Rutgers, the State University of New Jersey, and a PhD in accounting from Southwestern University of Finance and Economics, China. Dr. Sun is interested in the applications of artificial intelligence in accounting and auditing. Her research papers have appeared in Review of Accounting Studies, the Accounting Horizon, CPA Journal, Journal of Emerging Technology in Accounting, Intelligence Systems in Accounting, Finance, and Management. Hanche is currently a second-year doctoral student of the Accounting Information Systems Department at the Rutgers Business School. She holds a bachelor in finance from Southwestern University of Finance and Economics, China. Hanche research interests including applying machine learning and text mining techniques to accounting and auditing domains. Now we will start our seminar with Professor Miklos Vasarhelyi.
Thank you, Mohammed. Thank you for inviting me. Can you hear me?
Yes, very well.
Okay, thank you for inviting me. And I'm very happy to talk today. I have a long-term relationship with Egypt. We used to have an agreement with Tanta University, Rutgers, and so it has been a while. And I'm very happy to have Ting Sun, we call her Sophia Ting Sun, my ex-PhD student with me, and Hanxin Hu, our current PhD student specializing in machine learning. And Sophia's dissertation was also AI-ish at that time. And Sophia just got in an article in RARC, basically applying machine learning. So I would say Sophia is one of the world leaders in accounting applications of machine learning. So let's move forward. I'm going to take liberty of the opportunity because I want to do something here for public good. So Hanxin, can you move forward? Okay, first about the continuous auditing and reporting lab. Basically, our group, our AIS, Accounting Information System group, has been around for many years. And the CALAB was founded about 20 years ago. And according to Brigham Young, we have been ranked #1 in AIS for the last 30 years of research. And recently, people kind of discovered that continuous auditing is part of auditing. And so our ranking in auditing has gone up to #7 and continues rising. Hanxin, next one, please. And our group is very eclectic. Actually, there are very few American-born people. I look at this picture for 2 years ago, maybe 3 people born in America and everyone else in different countries. Go to the next one, Hanxin. And just to give an example, we work in many different areas. The group is around 50 people, and we are working with the Government Accounting Standard Board for seeing if municipalities are obeying their standards, program implementation review. We work with the state of New York using tweets to establish the cleanliness of the city of New York, and et cetera, et cetera, et cetera. Move to the next one, Hanxin, don't want to take time away from paper. Again, this is a whole set of projects we have been doing. Actually, I would like to mention Radar. Radar was a project we did for 3 years with the American Institute of CPA, the 8 leading CPA firms, and the Canadian Institute. And we did 2 projects there. One we called MADS, which basically full population testing and auditing. And the second one is in process mining, which is using logs to see transaction paths. And many of our projects today are AI projects using machine learning, using intelligent process automation, and other unsupervised learning techniques. Go to the next slide, please. This is the reason I'm talking about the car lab. I wanted to mention, this is kind of public good thing. You can click on that directory, on that URL there, and you can get our dashboard with that password, and you can get all the papers, many of the papers that are published. The other thing that's public good is we actually recorded, we have a very large accounting department, and we have recorded pretty much everything, every class we taught, and it's free at YouTube. So if you're interested in taking the CPA exam or teach your students what we teach in our university, you can just go there and see our videos, have them see the videos. In addition to that, we have about 800 hours of very state-of-the-art analytic instruction, and it comes out of our projects. We do a project, we do videos, and we apply it in our classes. Hanxin, go to the next one, please. And so you go in YouTube and you say Rutgers Audit Analytics, and this is what you get. Videos for free. They're good, good. Just don't have to go down. And then this, we are now in a big effort to start a whole new set of courses. And we are doing a certificate audit. They're mainly graduate, but undergraduates could take them too. And they apply AI, they talk about cybersecurity, and we give this certificate with 4 courses audit analytics. Go to the next one, please. And these are other courses like AI in auditing, this expanded set of, we call them SOCs, which are other audit type of certificates. And then we are talking about virtual currencies, automation, robotic process automation, blockchain, process mining. We are developing, already have these courses developed. Go to the next one, please, Hanxin. And we also do, and I think Samir was participating on it, our 3 PhD classes. We do them in an open basis. So what do? We teach the classes, and anyone that wants to attend can attend synchronously. And they every year are different because we improve our courses or we change our courses every year. In this example, my audit seminar, our survey, the survey seminar is very interesting because we are 11 faculty in AIS, and many of us just do one lecture on something AI. Like Kevin talks about text mining, Hussein talks about exceptions. I talk about continuous auditing, et cetera, et cetera. And Alex teaches a very technical machine learning seminar, Kogan. Okay, next one, Hanxin. I'm just going fast with this. So let's talk about this paper. This paper actually is a very privileged luck that we had. We were contacted by Professor Min Zhang on Renmin University, and he has a data set that provided by the Chinese government that gives us data about certain things in auditing that we can't get in the US. These adjustment estimates. And they have a large database on the CPA environment in China. So we thought this was a fantastic opportunity for application of machine learning. Let's go to the next slide, please. And so we are going to go in 8 parts, basically just tell you a little bit of the frame of this one, and then we are going to discuss the research questions, the algorithms used, validation, and I'll do some conclusions. Go ahead, next one, Hanxin. Okay, so what is the contribution? I always try to do this at the beginning of my seminars, because if the debate gets very heated, you never get to finish your presentation. So it's better to say at the beginning what you think your contribution is. This paper is going to be submitted to a journal, and we hope it will get in. If not, we'll send it to another journal. So here we have our contribution is a machine learning approach to predict audit quality with a wide range of variables describing characteristics of accounting firms, individual audit partners, and public companies in China. And we developed this thing called the surprise score based on traditional proxies of audit quality. And it captures unobservable factors that affect audit quality. It validates the effectiveness of these quality measures and can help regulators to make use of inside information about accounting firms for measure audit quality and identify suspicious activities. Next one, Hanxin. And what are results? Hanxin, are you taking over or I'm doing this slide?
Yes, I suppose you will still do this slide. The result.
Okay, I'll do this. Okay, so what do we find out here? That machine learning provides accurate prediction on audit quality proxy basis of non-clean opinions and audit judgments. Data describe the audit firm partners is an important role in prediction. And the constructed surprise score as a measure of audit quality is significantly associated with audit failures. The higher the surprise score for non-clean opinions, the higher the probability of audit failure. For the group of companies, extremely high surprise score for audit judgment, the higher the score, the higher the probability. This is not unusual, this kind of approach in the kind of research we do. You do some predictive analytics, and you use the predictive analytics in audit for pointing out to you as a proxy of the risk of a particular thing. We did a study with a company, the US company, with 2,000 outlets, and we wanted to decide which outlets we're going to audit. So we did the prediction compared with the declared actuals, and the difference, if it was very large, would be the one to be out. That would be like a type of surprise score. So guys, go to the next one and you guys take it over.
Hi, everyone. I just want to take the chance to say hello and thank you so much for the opportunity. This is Sophia Ting Sun. So let me talk about the background and motivation here. So we know there are many research studies try to use some ways to measure audit quality. Here we list some examples. For example, the abnormal accruals, if there is any meet or beat analyst forecast, financial restatements, going concern opinions. But their downside is that they all comes from externally observable data, which means the researcher have access to those data that they are not come from the internal sources. So if we're just trying to measure all the quality based on those observable data, it just indirectly measure all the quality. And in 2015, Bell and etc. says we use those indirect measures. They are pertaining to different type of financial reporting and other audit related outcomes. So even though we use them collectively, still we could not provide a relatively complete picture of the audit quality. Next slide, please. So in 2014, DeFront and Zhang, they stated that there is no single category could paint a complete picture of audit quality. So they recommend the researchers use multiple proxies from different angles to measure the audit quality. So we can help thinking about how can we find an alternative way to help us capture those unobservable factors for audit quality. Next one, please. So speaking of those unobservable factors, those are called unobservable because they are internal information. We do not know what exactly they are. So it could come from the auditor side or from the company's side. So again, we provide several examples of them, and they are much more, like the management incentive to falsify the financial records, like the weaknesses or the significant deficiencies in the internal control that haven't been identified by the auditors or the management, like the social or economic bondings between the auditor and the company, or if the company, accounting company got sufficient or relevant evidence to support the audit opinion. And also there are some factors related to accounting firm culture and the personal skills and the qualities of partner and accounting staffs and so on. So next one, please. So here in this research, we try to answer 3 research questions. The first one is, because our goal is trying to measure audit quality. So what could be the most important factor for the prediction of audit quality? And second one is, how can we construct a new measure of audit quality that could capture those unobservable factors or the outcome of those unobservable factors? The last question is, how, once we got this measure, how can we validate them? How can we demonstrate its applications? So the next slide shows us, the next one, please, shows us the research design. So for this research, we have 3 different steps. We're going to start from step 1. So for the step 1, at this initial stage, we try to make machine learning models to predict the audit quality. So here, if you look at this proxies of audit quality, we are not start looking at those some unobservable factors. We're not at that stage now. We just try to identify different measures. Some of them, they are traditional. For example, the non-clean audit opinion. So if there is a non-clean audit opinion, then it equals 1. Otherwise, this variable equals 0. Or we have another measure, which is financial restatement. Actually, this is the earnings misstatements. So 1 or 0, this is dummy variable. So these 2 variables, they are actually the traditional audit quality measure. And then we also include audit adjustments. And because the unique of data, we got this data from the Chinese Ministry of Finance. We got audit adjustment data from different types. We have all of those 6 types of audit adjustments. So if there is like a net income adjustment, then it equals 1. Otherwise, it equals 0. So we totally have 8 audit measures for now to measure audit quality. Again, this is not our proposed audit measurements. And we try to make prediction model with machine learning. And what are our predictors? Our predictors include a wide range of data features describing the company's financial situation, the audit firm's characteristics, as well as the audit partners' features. We'll talk about this data in 1 second. So once we develop our model, we expect to make prediction, and the prediction is the probability that a certain event out of these 8 events will occur based on the past behavior of our data, based on our predictors. And then we test our accuracy for the prediction with our testing set. And if the result is good, which will be shown to you later by Hanxin, then this prediction is what are expected to happen. That is our expectation, okay, given the current value of our predictors. Next slide, please. So step 2 is, right now it's time for us to construct our measure of audit quality. So we compute a score called the surprise score. which is actually the differences between the prediction that we provided from step 1 from our machine learning model and the actual value of the event. So this is the formula. Let me give you an example. So let's say the predicted probability of a non-clean audit opinion is 0.99 based on our machine learning model. But the actual value of that event is 0, which means the company never received any non-clean opinion. Okay, so here you can calculate the surprise score as 0.99 minus 0, which is 0.99. That is a very high score, which is very close to 1 because 1 is the maximum value of this score. So a high surprise score would indicate a lower audit quality because that means the auditor's propensity to issue a non-clean opinion is lower than what should be expected based on our data. Okay, so we know there are some unobservable factors that drive the actual value of a certain events deviates from our expectation. So the surprise score should be the outcome due to those unobservable factors. So that's why we say this score could capture the outcome of unobservable factors. Okay, next one, please. Okay, so right now we have the surprise scores ready, but how can we validate them? So for this, we try to examine the relationship between the surprise score, which is a measure of our audit quality, and audit failure. Okay. Of course, we include all of the control variables used by prior literature, and we will try to see if we can observe a significantly and a positive relationship between the surprise score and audit failure. Okay. We also want to do a comparison. We replace surprise score with the traditional audit quality measures, try to see if the same pattern exists. Okay, so that is our research design. Next one, please. So now let's talk about the data. As I promised earlier, we will talk about this. Okay, so dependent variables, you know that this is for the step 1. We have 8 dependent variables. Okay, and for the independent variables, we have 73 original variables. Out of those 73, there are 27 variables is describing the company, and those variables they all comes from the prior literature. So we got that. We follow the prior literature, collect all of those 27 company level characteristics. And for the audit firm level characteristics, so those 28 variable comes from CICPA, Chinese Institute of CPAs. So they provide features like what is the revenue of their firm, the audited firm, what is the number of subsidiaries, net assets, number of employees, the salary of their employees, and so on. We have totally 28 of them. And for the audit partners, it also comes from CICPA. We have their detailed information like the education level, the gender, the age, experience, their title, birthplace, and so on. And then we'll also include 3 macroeconomic variables. So in total, we have 73 as our independent variable for the step number 1. Okay, and our research period is from 2010 to 2017, and sample size is 11,574. Next slide. Okay, so here is just some description about the distribution of our observation over a year. So as you can see, we have the research year from 2010 to 2017. And I just listed the total assets adjustments because all the other 5 adjustments, they are similar. So I just provide one example, which is the total assets adjustments, and also provide examples of non-clean opinion and the financial restatements. Okay, so if you look at the total assets adjustments, our total observation is we have 1 observation in 2010, 57 in 2011. The reason we have so few is that when we merge the data from audit firm and the audit partners, we have a lot of missing variables, missing values. So we have very limited number for the initial 2 years. But for the following year, we have enough observations. And those numbers, they are the total records. And the next column is the proportion of adjustment. For example, if you look at 2012, the total observation is 2008, and they are approximately 61% of them. The companies have total assets adjustments. So you can see the data is balanced. Okay. And also we do the similar thing for the non-clean opinion. But if you look at the non-clean opinion, let's say just look at the 2014 for the non-clean opinion, 2014. So the total records is 2,322, but we only have around 3% of them, they have non-clean opinion. So as you can see, we have a very rare case for non-clean opinion that is imbalanced data. So later on, Hanxin will talk about how can we use a machine learning algorithm to fix this problem. And we have the similar pattern for the observations for the earning restatement. Okay, so that's all for this slide. Next one, please. Okay, so speaking of machine learning, of course we need to separate our data into different groups, right? So with our 4 sample sizes from 2010 to 2017, so we used all of the observations during the period from 2010 to 2014 as our training set to train our model. And then we also need a test set. So from the data from 2015 to 2017, we randomly pick some data as our testing data sets, and we make sure the size of the testing data set is 20% of the size for the training set. So you can see the number of the observations for the testing data sets. Okay, and then for the same period from 2015 and 2017, we have some unused data. So for the rest of this unused data, we reserve them as our application data set. So the application data set is used for validate our surprise score, and we apply that to our audit failure tests. Okay, so next slide, please. So this is a flow chart for the whole picture of our steps. So as you can see, the 4 sample has been separated into training set, testing set, and application set. So remember we talked about step 1. Our goal for step 1 is trying to develop machine learning to predict those 8 events. So we use the training set and the testing set to do the model development and the testing. And Hanxin will show you what is results of our prediction model. And step 2, later on, please go back. I haven't finished, sorry. And step 2 is we use the application data sets, and based on the model we developed, we use the application data sets to calculate the surprise score. So we got surprise score for each of the observation in our application set. And the last step is we validate our scores with our audit failure tests. Okay, so I think that's all for my part. Hanxin, you can take it over.
Okay, thank you, Sophia. Hi, everyone. This is Hanxin. Now I will take over this presentation. Before we talk about the prediction results and validation results of this study, we will introduce some machine learning algorithms applied within this study. As you can see in this slide, basically we use 8 different machine learning algorithms to complete the prediction of the traditional audit quality proxies, including the random forest algorithm, XGBoosting algorithm, support vector machine, artificial neural network, gradient boosting algorithm, logistic regression, RUS boosting algorithm, and balanced random forest algorithm. Among all these kinds of algorithms, I have to mention that you can notice there are several methods that are belonging to the ensemble approach, including the random forest, XGBoosting, gradient boosting, RUS boosting, and balanced random forest. The basic idea of this kind of ensemble approach is actually to firstly construct some very weak learners. And the second step, we will try to combine the results, the prediction results generated by these weak learners and get the final results. In this way, we actually can get a more accurate and stable result compared with a single weak learner. And this is a basic idea for this kind of ensemble learning. And we should pay attention to that there are some difference between these ensemble learning methods. They are different in terms of the combination methods, such as the backing method or the boosting method. For example, for the random forest algorithm, this algorithm tries to combine the weak learner decision trees prediction result by simply averaging the single prediction. However, for the boosting combination, the pattern is a little bit different. The boosting method, like the XG boosting, gradient boosting, and the adder boosting, they may try to reuse all the refocus on the weak learners that cannot generate very good results. And through this iteration, they can finally get a significantly improved result. So apart from the ensemble approach, we also use the support vector machine. And the basic idea of this kind of algorithm is actually to figure out the optimal decision boundary between the two classes. For example, currently my task is to predict whether there exists net income adjustments. So if I use the support vector machine, what I need to do is actually to find a hyperplane or the decision boundary in the data space. And this kind of hyperplane can maximize the distance between these two classes. So this is a basic idea for the support vector machine. Now we also use artificial neural networks. As mentioned by the Sophia, you can realize that our data size is not very large. So in this case, we cannot use very complex artificial neural network structure, which can cause some overfitting issue. So in our study, we just use the 3-layer artificial neural networks, including the input layer, hidden layer, and the output layer. We suppose that by using this kind of artificial neural network, we can actually discover some underlying patterns existing in the data. And this kind of underlying pattern can help us to identify the two causes. This is a basic idea for the artificial neural networks. Also mentioned by the Sophia in the previous table, you can realize that there exists some imbalanced data issues for the prediction of restatements and non-clean opinion. To mitigate this imbalanced issue, actually we use two kinds of machine learnings to help us to deal with it, including the RUS boosting algorithm and balanced random forest algorithm. To be honest, the balanced random forest rationale is very similar to the random forest, whereas the rationale of the RUS boosting is very similar to the adder boosting. However, the key distinction there is that both RUS boosting and balanced random forest would like to do some downsampling operation for each iteration. More specifically, during each iteration, we will get a bootstrap data set from the minority class, and we will also get the same number of the observations from the majority class. In this way, we can mitigate the imbalanced issue by using these two algorithms. You can also notice that we also use logistic regression as our benchmark algorithm. In the prime literature, they would like to use this method because they are very efficient, which means that you can train the logistic regression in a very fast manner. And also you can explain the results in an easy way. And we use it as our benchmark method to compare the results with some more advanced machine learning algorithms. This is the purpose to use logistic regression there. Okay, after talking about a series of the machine learning algorithms used by this project, we will talk about the prediction results of the audit quality proxies. Before we discuss these two figures, figure 2 and figure 3, I would like to firstly introduce the evaluation matrix used by our study. As you can see in our paper, we actually use very different and various evaluation matrix to evaluate the prediction results, including the RC, AUC scores, the operations and sensitivity, and F1 score. The purpose there is that we would like to use different evaluation matrix to give a very comprehensive evaluation about our predictions out of the sample. This is a basic idea. as for the ROC curves shown there, you can see there are actually two axes. The x-axis refers to the false positive rate, and the false positive rate is actually defined as the percentage of the false positives among the number of the total electives. As for the y-axis, it refers to the true positive rate and is defined as the percentage of the true positives among all the electives. This is a basic idea of the ROC curves. As for the AUC score, it's actually the area under this curve. You can, sorry, yeah.
We have a question from Dr. Samir Trabosi.
Yeah.
Very, very interesting presentation. My question is, these modified opinion, are sensitive true to the hard numbers, okay? But sometimes also the tone and the, of the annual report tells something. My understanding is that you apply the machine learning algorithm to the hard numbers, right?
That's true.
Did you apply it to the kind of soft disclosure around those?
No, not yet. Not yet. We haven't done any text mining on this. Eventually, is not a bad idea. Correct, Sophia?
Yes. And actually, we have another project trying to exploring those soft disclosure thing. This is a very good feedback.
Yeah, because we are focusing on the Chinese data. The issue for the Chinese texture analysis is that can be much harder compared with the English textual analysis. But this is a very good idea to incorporate the Chinese textual data into this project.
Yeah.
Now, my follow-up question then, if it is applied to like the hard number, I see from the, I don't know the detail of the variable, but did you work with composite? Like, for example, you can look at accruals, you could look at free cash flow, you can, because all this clean opinion, all these auditor opinion are sensitive to the balance sheet, it's a combination between the balance sheet and the income statement, the statement of cash flow. Did you try to kind of find a kind of a composite? For example, you look at free cash flow, you look at discretionary accruals and try to fit them in the algorithm,
Do you mean using them as an independent variable or dependent?
Yeah. I would say as a dependent variable, yeah.
As dependent variable, yeah, we can try that too, yeah.
Because your dependent variable now are stock variable, right? Income tax, total liability. These are stock variable. I would argue that you kind of use not ratio, but a combination, like, the free cash flow is an indicator, accumulated loss is an indicator. Or you can even look how many years the company has losses,
How many years what?
How many, for example, as auditor, I'm gonna, has a clear paragraph around going concern. One of the indicator is the company is accumulating losses, has been earning losses across the years.
Okay. Loss.
But this is fascinating, honestly.
Yeah, we can use more, definitely. Yeah. Thank you so much for the feedback.
Yeah.
Another question from Ray Marche. You can open your mic, Ray. You can open your mic and ask your question.
Yes, I also noticed this. Another question, could this type of model can be used by the regulatory bodies? I suppose regulatory bodies can also use this kind of model. You know that this kind of, for the China, the Chinese finance ministry and the Chinese CPA has kind of this data. Of course, they can use this kind of models to do some monitoring issues.
And also, just to add on that, you know, the audit adjustment data, they are available for the accounting firm. So let's use US as example. If the PCAOB requests the accounting firm to provide those audit adjustment to them, the PCAOB can also use our approach.
Yes.
If they request the adjustment data, it would be a big pushback, but I think it would be a very good idea.
If I may add one minor thing, you know, because I do really like this. You know, I attended once a talk by Mark Defoe on the challenge to capture audit quality, and that's why I do really like this paper, you know. And his argument was there is a problem in capturing audit quality both at the supply level and at the demand level. I'm going to look to my email and I'll find out that talk, because I even asked him to share with me his slides, and he lists a kind of variable that make capturing this audit quality at the supply and at the demand very challenging. So I'll share that with you. Maybe you may have to look at it and identify, even in your independent variable, some indicator from the supply and demand. And your model is quite really impressive, really.
Thank you so much for the comments.
A question from Ahmad.
Hello, everyone. Thanks you for this valued seminar. I have two questions. My first question is, have you used all of these algorithms in your article? And my second question is, having mentioned the text mining, based on your knowledge, what tool can be used for text mining?
I answered that online. There is a wide range of tools in Python and in R, and there is an ensemble called Orange that's very, very useful, and they are all free. And of course, there are proprietary text analytic packages that you can use too. There is a large number of tools, and there is a large number of technologies for text analytics. And there is a lot of brute force type of technologies used by speech recognition, by Google questions, etc. So this is a whole field on itself. If you send me an email, I'll send you the syllabus of Professor Kevin Moffett text mining course for PhD students, which, by the way, I'm sure that if someone wants to sit in remotely when he teaches it every year, I'm sure he will be agreeable to it.
Thank you so much. Can you provide your email for us, please?
It's Miklos V, MIKLOSV at Rutgers EDU.
Thank you.
I'll write it down.
A question from Angie. Can open your mic. Okay.
Okay.
Hanxin, I saw the question from the chat box saying that, do you think we can predict the financial performance of firm using machine learning, and what tools we can use in prediction?
Of course.
Yeah, of course we can use that. Yeah. And also for the machine learning algorithms, we can definitely use the one that we used, and there are many other algorithms. Hanxin, you want to talk about that?
Sir, can you repeat it?
Yeah, and also we haven't used like a more basic like decision tree. If the goal is just trying to predict the performance of companies, depends on the size of data, we can use decision tree as well. There are hundreds of algorithms, and the tool we're using Python, right?
Yeah. Actually, I want to complete this answer. Actually, we have used some other machine learning algorithms like decision tree, live base, and KNN. We use these methods for the prediction. The the question why we do not put this, the issue we do not put these algorithm results in our paper is that the KN decision tree cannot give us a very good prediction results for the target events. So we only include this kind of algorithms which can return a good predictions to us.
Yeah, and we actually tried more algorithms
Yeah.
than it. And also there's another question. Do you think you can improve prediction further by using a RNN, which is a deep learning approach? I think Hanxin mentioned that before. Do you want to repeat that?
Yes, I will repeat it. Perhaps you can see our data size for the training, which is around 6,000 observations. In other words, the data size is not very large to support the training of the RNN or much more complex neural network structure. So in this sense, we find that the very simple neural network structure like 3 layers can give us better results. I suppose if we use more complex constructor, that can cause some overfitting issue, which will make the prediction results more terrible.
I think we did one deep learning,
Yeah,
and the result is terrible.
yeah, that's true.
Okay, I think you can go ahead, Hanxin.
Okay, thank you. I will continue for the evaluation matrix introduction. As mentioned before, the AUC-RC score actually the area under the RC curves, and the perfect situation you can consider is that the RC curve will pass through the entire upper left color. This is a perfect situation, and in this case, the AUC should be equal to 1, and this is the maximum value for the AUC-RC score. After introducing the basic idea about the evaluation matrix, I will show you the prediction results. As you can see on the left hand, the figure 2, we actually present RC curves and the corresponding AUC scores on the test set when we use the net income adjustment as our dependent variable. As you can see in this graph, basically we use 6 kinds of algorithms, including random forest, XGBoosting, SVM, gradient boosting neural network, and our benchmark algorithm, logistic regression. According to the out-of-sample performance on the test set, we can see that the random forest and XGBoosting has the best performance with AUC-RC score equal to 0.77, which is good. And we actually also perform the prediction analytics and the evaluation analytics for other kinds of audit adjustment variables. And the result is very similar to the net income adjustment. So due to the time and the space limit, we only put a net income adjustment result there. Okay, I notice there is another question. Okay. Now I will show you the prediction results for the long-clean opinion on the figure 3. In this case, as mentioned before, the long-clean opinion prediction is actually suffering from the imbalanced data issue. In this case, we basically use 2 algorithms, including balanced random forest and RUS boosting, to do the prediction. As you can see there, according to the AUC-RC score on the test sets, both of these 2 algorithms can achieve very high AUC scores, which is equal to 0.92. This is a very good prediction to the non-clean opinion. Note that actually we also perform the prediction for the earning restatements, but the resulting AUC for the earning restatement is not very favorable, which is only equal to 0.64. So these results actually are not surprising. This is because the earning restatement itself is a very noisy proxy due to the existence of the false negatives. We know that there are basically 2 issues of this earning restatement method. The first issue is that the time laggings, which refers to that there exists some laggings in the reporting earning restatements. And another issue is that the regulators may have very limited budget and they cannot invest sufficient efforts to identify all the misstatements. All these two kind of issues make the earning restatement very noisy, and our predictions is also not favorable, and we will not put it in the slides. This is the reason. Okay. Apart from the prediction results, we also try to identify which kind of group is the most important and predictive to the target event. Actually, this is our first research question, and this kind of analysis can answer this research question. Basically, we use the impurity-based method to identify the top 13 important features for each target event. And this slide shows you the top 13 important features for the prediction of net income adjustments. Well, according to this figure, we can answer this question, which group is the most important? We draw this table to do some calculations. The first column refers to the categories of the factors, including the audit firm characteristics, audit partner characteristics, and the company's characteristics. And the second column refers to the percentage of the number of this kind of factors among the top 13 features. According to this calculation, it appears that the audit firm characteristics are the most important features when we are trying to predict the existence of net income adjustments with the proportion over 60%. Additionally, we also realize that some features like the partner's experience and the company's financial situations are also associated with the dependent variable, the existence of net income adjustments. Note that we also do the similar feature of importance analytics for other audit adjustment variables, and the results are very similar to the net income adjustments. Okay, we are going to this slide, which show you the top 30 features for the prediction of non-clean opinion. And this can answer the question, which group of the factors is the most predictive to the issuing non-clean opinion. Also, according to this calculation, we can draw a conclusion that it's obvious that the company's inherent characteristics are the most important features when we are trying to predict the non-clean opinions. And additionally, we also find the partner's experience and the audit firm's financial situation are also associated with this variable. Okay. Now we are finishing the discussing about our prediction results. Now we are going to the most interesting section of our paper, the validation. Sorry, is there any question? Okay, I will continue. Recall that the purpose of this validation section is actually to validate the effectiveness of our proposed supervised score by comparing the indicative power to audit failure between the surprise scores and the corresponding traditional audit quality proxies. This is the purpose of the validation section, and this table shows you the details about this empirical design. As you can see there are basically two models there for each audit quality measure. For example, for the non-clean opinion, in the model 1, the dependent variable is the penalty due to the accounting violations. And the independent variable is the surprise score of non-clean opinion based on the machine learning methods. In contrast, in the model 2, the dependent variable is also the penalty, whereas the target independent variable is the corresponding traditional audit quality proxy, which is a non-clean opinion. Then this variable will be equal to 1 if a non-clean opinion is issued. For the audit, sorry, there's a question.
Yeah, this is
looking
similar.
at.
You know, your surprise score, you know, because I'm a little bit, you know, excuse my ignorance. I have no idea about this machine learning business. So your surprise score, is it a score that capture the rational expectation of having a clean opinion, but we end up with a non-clean? That's what's capturing?
Perhaps I can show you the slide of the calculation formula.
Yeah,
Wait a
but
minute.
what's it capturing?
As you can see there, our machine learning models will use a wide range of the observable factors, like the company level features and audit firm level features, to predict the probability of the events. For example, for the non-clean, yes.
Sorry, your event, what is it, this event? Is it the event, for example, it could be the event around clean versus non-clean. It could be meeting or beating analyst forecast. So the event could be anything, or the event is audit related?
In our paper, the event refers to the existence of the audit adjustments and the issuing non-clean opinion. This is the event, two events.
Move to the last slide. We have the list of just the last one.
Is this one?
No, the one before the formula.
Okay. This one?
Yes. So though we have 8 types of events. For example, if there is a, excuse me, if there is a net income audit adjustment, then it's 1. Otherwise, it's 0. So we have 6 types for the audit adjustment event. And we also have the event for non-clean opinion. And we have the event for the existence of financial misstatements. So we measure 8 different events. So if we go back to the next one, next slide, Hanxin. So for example, let's say because we develop model for each of those events. So let's say we develop model for the issuance of non-clean audit opinion. So let's say the prediction is 0.99, but the actual case is 0, which means there's no non-clean opinion. So in that case, the surprise score is 0.99, which means auditors, they never issued any opinion, but we expect that they should. That's the surprise score. Okay.
Very good, very good. Yeah.
Okay, thank you.
Actually, I want to make sure about something about the formula. So, like, is it absolute value or just the predicted probability minus the actual value? Or after that, you take the absolute value?
We didn't take the absolute value because it is possible we have a negative score, which will be discussed later on. That is another case. Hanxin.
Yes. Yeah. Actually, when the surprise score is selective, this is a case when the auditors is very extremely conservative. Okay, I will continue. For the other audit adjustment variables, we also use this kind of empirical design. In other words, we have 2 models there. In the model 1 is a surprise score generated from the machine learning models. And for the model 2, the target independent variable is a corresponding traditional audit quality proxy. And this is the empirical design of the validation section. Now we will have a look at the validation results shown in this slide. Basically, there are 3 tables, and I will discuss the tables one by one. In the first table, we want to compare the predictive power between the non-clean audit opinion and the non-clean opinion surprise scores based on the entire validation sample. As you can see there, we can observe the estimated coefficient for the non-clean opinion surprise score derived from the balanced random forest is significant and positive. However, the estimated coefficient for the corresponding traditional audit quality proxy non-clean audit opinion is negative but non-significant. So the issue there is that we can say our surprise score, non-clean opinion surprise score, is more indicative to the audit failure. And we also report the pseudo R-square and one test there. Both these two metrics tell us that the model of the surprise score is more favorable compared with the model with the traditional audit quality proxy. Okay, we will talk about the second table. In this table, we try to compare the predictive or the correlation power by using the net income adjustment and the corresponding surprise score to the audit failure. As you can see there, we realize that none of the estimated coefficients is significant. And according to the pseudo R-square in one test, we realize that there is no significant difference between these two models. So we try to figure out the potential reason, and the reason is the fact that the existence and the amount of an audit adjustments are based on a negotiation between the auditors and the clients. When the parties cannot reach an agreement on the adjustments, in this situation, the auditor actually will issue a non-clean opinion. So we can see that the issue of the non-clean opinion is a final outcome as well as the worst case of the negotiation. So in the evaluation of the audit quality, the difference between the models predicted and the actual value for the audit adjustments will be less severe than for that of the non-clean audit opinion. This is a rationale behind it. Because the surprise scores for the audit adjustment as a whole is a relatively mild measure of the audit quality, it cannot be used to effectively predict audit failures that are very severe as a penalties. So our research will then focus on the two subsamples with extremely high and no surprise scores to investigate among those relatively rare cases whether the surprise score is significantly associated with the penalties. And the slides show you, the third table show you the comparison between the net income adjustment and the net income adjustment surprise scores within the two subsamples with top 25 and the top 10% surprise scores. So you can see there, the two subsamples only consider the very extreme situations. In these situations, the surprise scores are very high. In other words, the auditor are very aggressive. They should issue the net income adjustment, but the reality is that they do not issue the net income adjustments. Now we will have a look at the results. The estimated coefficients for these two subsamples net income adjustment surprise scores is positive and significant. And we also observe that the pseudo R-square is much higher compared with this table. In this sense, we can see that the net income adjustment in the extreme cases can be indicative to the audit failures. This is a basic idea we can get from this test. Okay, we're going to the final sections of our paper, the discussion and the conclusion, and Professor Miklos will take over it.
So basically just, I would like to point out that this is pretty much a unique paper because the data is data that is not available elsewhere, but some of this idea of surprise score is applicable also even with American data. It's comprehensive. It includes accounting firm characteristics, partner attributes, and adjustment data. And if in the US, we actually tried to work with one of the big four in another country in Europe to see if we could get private adjustment data, but we, up to this moment, didn't. And so we are very happy with this type of data that we can do. And we learn a lot by doing that. Now, just a couple of comments about machine learning. First says that it takes advantage superior to machine learning to identify hidden patterns, make accurate prediction for complex multidimensional data. Many of you will remember that most of the papers in the past took something like logistic regression and tried to do something with it. Here, and in many of the machine learning studies these days, you have a fruit salad of methodologies. You choose a whole set of methodologies. We used many of them here, analytic methods, and finish up finding out the results that were the most interesting results with the method that is more interesting. This is the result, same thing in artificial intelligence. Now with the major improvement in power of computers and availability of data and ability to process data, you can do much more with it. So that's kind of where we stand on this one. And Sophia and Hanxin, do you want to add anything?
I'm good.
Yeah, I'm good too.
So the study proposed machine learning-based audit quality measure surprise score. The results showed that the predictive accuracy is high. And third one, the validation, meaning the validation of the method, shows that compared to existing audit quality proxies, the surprise score based on non-clean opinions are more indicative to audit failures. Based on subsamples with extreme high surprise scores, audit adjustment surprise scores are indicative of audit failures, whereas audit adjustment totally lose predictive power within this context.
Okay, if you have some further questions, you can ask.
Thank you very much for this excellent presentation. Now, a question from Dina. Daya?
Yeah,
Yeah, you can ask.
I have two questions. First one, how to measure the artificial intelligence impact on firm value and performance? The second, what type of artificial intelligence techniques applied by majority of firms that can increase its and the performance?
Yeah, can you just repeat your second question? I didn't understand it.
Okay. What types of artificial intelligence techniques applied by the majority of firms that that may increase its value?
Okay, let's start from the beginning. Can you just repeat your first question again?
How to measure artificial intelligence impact on firm value and performance? The impact of artificial intelligence on
No,
firm value.
You are asking about fair value, meaning the former paper by Sophia and the group was basically dealing with estimates. And estimates are a product of fair value, meaning in the old days, the way companies manage their accounting is that they created reports and progressively took advantage of the flexibility that accounting reporting allowed for disclosing the results in the direction they wanted it. When things got bad, they basically do a big bat, as they call it. They did a big write-down. In my years at AT&T, they did two very large write-downs. So within the rules, so it wasn't like defrauding, etc., was within the rules. Now, after fair value was adopted, it increased substantially the possibility of maneuvering numbers for the results you want. The number of big bats basically went down substantially because you could use your estimates in the direction you want. Then, Sophia and our group decided to study estimates. And in this estimates, basically the paper on estimates looked at estimates made by insurance companies on the future obligations under the current insurance contract on insurance claims. And basically, we use a whole set of AI methods, basically, it's not AI methods, different type of algorithms that predicted what were going to be the liability. And because the data was a long-term data, we could ascertain if the results of our estimates were good. And the machine learning approach in that particular case, in 4 out of the 5 insurance products, was substantially better than company estimates. The 5th one that was not substantially better was for a particular insurance product that have a very short life cycle. Therefore, in 1 year, pretty much most of the insurance was resolved. So, but in the other 4 was surprisingly high and powerful result. Sophia, you want to add something to that?
Yeah, and also for my personal experience, the most powerful machine learning algorithm is random forest. It always has the best result, even for that project and for this project. So I think that answers the question about which one is most popular.
Yes, for the classification question, just as questions for this paper, we just realized that for the audit adjustments and for the non-clean opinion, perhaps the best performance of the algorithms is also generated by the random forest for the classification question.
Yeah, but you know, it's that's a tough question to answer. What is the best method? In our studies, random forest surprisingly has been substantially positive, but we don't know in other contexts with other technologies, variations on the method. You never really know what's going to happen, and I think there are actually a couple of products or a couple of software in the public domain that actually already bring together several of the techniques and run all of them in a particular set of problems. Correct, Sophia?
Yes.
A question from King.
Yes, thank you very much for the splendid presentation. I think I'm learning so much. But I want to ask a question. Having that the Chinese contest had much data, in Ghana, Africa, where I have some sort of data, but not enough. I want to ask that, did you have all of the data points available, or there were some data points that were lost and you were able to use some processes to fill in those empty data spaces before you run the algorithms? Thank you.
Okay, so let me answer this question. So the reason for the Chinese we have more data is that this is a requirement from the Chinese Ministry of Finance that all the audit firm must provide the data of audit adjustment. But that just provided to the Ministry of Finance. This data is not public, but the Ministry of Finance have the data. And when we talked to them, they said we can use data just for the research purpose because they need a model that they can use to help them monitor the industry. And of course, we have many missing values. That's why when we show the data distribution for the year 2010, 2011, we only have like a 1 or 2 observation. That is because some of the data they are missing. So when the data for a variable is missing, we just delete the entire observation. And of course, we have other variables. They only have like a part of them missing like less than 15% or less than 13%. In that way, we use machine learning techniques to take the mean or median value, try to replace that missing data. That's the most popular way to dealing with the missing values.
But King, in analytical methods, there are ways that you can, for example, interpolate. You don't have data for 1 year, but you have the year before and the year after. Then what you do, you interpolate, take the average, or give or estimate based on higher weights to the more recent data. There are ways to interpolate the data, but every time inventing some data, you are losing some information value. Okay, but you in case you have a very spotty data set, you know, the question is, don't you do it or you do it? It's not a question of you have to estimate if how much quality you lose with this, and so meaning many countries have the problem of lack of data, and one of the problems about many of these machine learning AI type of things is that in current methodologies require very, very large data sets, meaning with the type of data sets that you use, for example, image recognition, you're talking about Google using millions and millions of images to create some recognition. Now, there is a whole set of techniques to reduce the needs of data set. But, you know, again, same kind of thing, interpolate, reduce data set, quality goes down. Interesting, the National Science Foundation, was DARPA, had a study, and they were talking there that takes computers millions of images to recognize something, but you show a child image of a letter, in 3 or 4 observations, the child can recognize. So obviously there are algorithms, maybe mental algorithms, whatever, or hardware that you have in your brain that you don't have in a computer that might eventually be better. One other thing is that I think, Sophia, you know more than me in this, but I do think that that there is a bias in each algorithm that you use. And if you find one algorithm better than the other, it's because you're either exploring well the bias, or you are creating a bias in your results that are not, let's say, accurate with reality. So, Sophia, talk a little bit about that.
So the reason why we want to use multiple algorithms is depends on the data, the representative of data, the nature of data. We have to try different algorithms. Some data, the algorithm works well, but for the same algorithm, it may not work well for the other type of data. So to avoid those bias, we try multiple, a combination of different algorithms. And also, Hanxin mentioned we try the resemble method, which is actually we use different weak learners, and we will combine them, and we take the vote for the best prediction. So again, like Freddie said, there's no free lunch theorem in machine learning, meaning there's no algorithm can always outperform other algorithms. Depends on data you have, depends on the size of data you have, depends on the techniques you are using.
Depends on the natural distribution of the data, correct? Meaning if the data is very linear, regression might do very well, better than anything. And I don't think there has been enough research on understanding, you know, like a good method of recommender system to tell you which method to focus on. Correct, Sophia? You know the literature better than me.
So that's why we always try the brute force approach, like a horse race. We just use multiple of them and to see which one give us the best prediction. That's true.
A question from Muhammad Taleh Hafzallah.
Yeah. Hello, sir. My question for you is, have you considered using recurrent neural networks for this to improve accuracy even further?
I think Hanxin just answered that question. Do you want to repeat that?
Yes, I can repeat. The issue we have is that the data size is not large enough. In other words, we cannot use too complex neural network structure. If we use some neural network like this kind of algorithms that can give us some issue like overfitting. In other words, the performance on the test set can be terrible due to the overfitting. In this case, we actually try different kinds of neural network algorithms, and we realized that the most simple structure, like a 3-layer structure, can give us the best out of sample performance. And this is the reason why we use it.
Yeah, meaning this is what example that I was talking about image recognition done with thousands or millions of of elements or millions or sample of millions. And when the samples go small, multiple level machine learning using what we call neural networks doesn't work very well.
Yeah.
A question from Professor Samir.
I'm gonna do like the unkind reviewer here. Yeah? Look, so you guys find that the surprise score avoid the type 1 error, which is like giving a clean opinion for a non-clean firm on the tail, right? When you take the worst case scenario, you have good results. Now what happened of those firms that are far from the tail? Why the surprise score does not perform well? Did you kind of have a kind of even intuition about that? Is it there is no, because my guess is you find good results because the standard deviation on the tail is very high, and that's why the surprise score has a better predicting capability of audit quality, is better proxy. Now, I'm trying to think why the surprise score does not work outside those extreme tails.
So let me try to answer that. So when we use non-clean opinion surprise score, the result is very good for the full population is very good. The reason is that non-clean opinion is the worst case. When the auditor cannot negotiate with the client, they have to issue that. So once they issue that, it's a big issue. So that would be significantly related to the audit failure. But surprise score is different. Surprise score has a very wide range, and we only find that for the extremely high surprise score group, it is indicative to the audit failure, but for the others, it is not. The reason is that, again, this is the negotiation between the client and the audit firm. So this is not the worst case. Surprise score is a measure of audit quality, but not so severe to lead to an audit failure, because audit failure is the worst case. So surprise score is kind of a mind. So that's why we can only look at the extremely high score group and see any indicated power. But for the others, like in the middle, it's like a mind value. So we should change our dependent variable, not using the audit failure. Audit failure is too severe. And another part for this question, thank you so much for raising the question. Actually, we are working on another part. And there is another professor raised a question, how about the negative score, right? The negative score is kind of indicating the auditors, they are super conservative. But the super conservative, does that mean a good thing? No. We talked to the partner of one of the big four accounting firm, and he mentioned that when the auditor is super conservative, they actually increase the cost, which is not a good thing. So for some sense, we can think extremely low score of surprise score could be also an indicator of bad audit quality. But again, we shouldn't use audit failure as its dependent variable. We should use something like audit change. Let's say if the auditor is too conservative, maybe next time we change it. We change to another firm. So we can use audit firm change as our dependent variable to validate the relationship between a low surprise score and that variable.
One small question, if I may. Can I, Mohammed?
Yeah.
Yeah, I'm sorry. I really like the paper. That's why I'm asking a lot of questions.
Thank you so much for the question. We really appreciate that.
Yeah,
really
did you try to, every time you come out with a new measurement, like, we challenge it by the validity, of this measure, you're going to get challenged on this. I have a paper on a construct, all the reviewers, they come back, say, we're not sure that you're measuring what you're saying you're measuring. Did you try to kind of look at, for example, non-audit fees, something like a proxy, and correlate it? And I'm pretty sure that you're going to find that your surprise score correlate with some classical proxy of audit quality, That will ensure the reader that you guys are really capturing what you intend to capture.
Hanxin, you want to answer that question?
I promise this is my last question.
Oh, so you mean that why not use some other events like audit fee or the some discretionary of law as an event to measure such kind of surprise score? Actually, we have tried this kind of events, but I have to say that the result is not very good. This is because something like audit fee is a little bit noisy, and you cannot find out a very good correlation between our features like audit firm features and the company level features and the audit fee. So I have to say that the audit fee is a little bit noisy, or the discretionary of law is also very noisy. So the prediction is not very good. As you can see in our paper, we also use some noisy metric like earning restatement. Restatement is also suffering from the like a false negative thing. So this kind of noisy feature cannot give us a very good prediction, and this is the reason we only use the audit adjustments and the audit opinions to construct the surprise scores.
Thank you. Good luck with the paper.
A question from Professor Amir Michel. You can open mic. You are very welcome.
Hi, Sophia. Hi, Enzo. Well done. Great presentation as usual. It's more of a suggestion or some suggestions rather than question, really. First of all, I think you're having a very good novelty here around some kind of the new measure about the surprise score or like that. Might be to get some kind of more generalization power to the novelty of you got. Might be you need another one step over the validation in terms of doing some kind of robustness checks like sensitivity analysis, and that might include different things. For example, if you've done supervised machine learning approach, what about switching it to unsupervised and see what the impact? Something else, of course, you're looking at partner characteristics and audit firm characteristics. There might be some leading and lagging effects, so it might be something we can introduce to show some robustness, especially that the pseudo R square is relatively low, which is expected because it's a new proxy you're introducing here. So I don't think it's a problem. It's just about more emphasis on the generalization power of the novelty of the paper to make it more publishable. And something I'll share with you next week. Next week there is a paper publishing coming in online. It's more about the dysfunctional behavior of auditors based on the time pressure and the budget pressure, and that's including fees. And it's very behavioral research paper. It's not using lots of, it's not a lot of numerical figures. It's using more behavioral scores. So something alongside what you're discussing here about the surprise factor. So I think that the robustness checks will give it more generalization power, as Miklos mentioned, to be generalized in other contexts. So I mean, the other thing, you don't want the reviewer coming and say, yeah, it's fine for China, but it's going to be very Chinese related. And I think there is a potential to be generalized. So I think those kind of robustness checks will give it some more generalization power. So just a suggestion, but well done. I think is great presentation as usual, and a great potential for the paper for publications.
Thank you so much for the suggestion.
Thank you.
A question from Ken.
Thank you so much for this wonderful presentation. And actually, this is one of the most original papers that I have heard in the last 2 years, because now the accounting literature is going around in cycles and the results are not making any point to the contribution. Even the papers are saying they are making a contribution, which I completely disagree. This is my, by the way, humble opinion. My question will be this: did you ever consider adding the accruals or يعني discretionary?
بتاعتي أنا. لا أنت ولد، مش حاجة اسمها من إيدي، عيب.
Someone has a kid, that's the part of life. But يعني for example, in your model, I didn't see anything related with the discretionary accruals. For example, did you consider adding it to your model because you know audit quality and accounting quality, financial reporting quality, these are not distant from each other. Although when we talk about audit quality, we are not talking about the accruals quality, but they are affecting each other. Maybe they have a moderating effect or mediating effect to each other. Yani,
We actually
this
did.
is my question.
Thank you so much for the question. We tried that. We tried abnormal accruals. Hanxin, you want to repeat that?
Yes, I can repeat it. Yes, thank you for your question. We actually try to do this, try to construct the surprise scores based on the discretionary accruals. But I have to say that the regression prediction is not very favorable. Our explanation is that the accrual, the discretionary abnormal accrual itself is a residual, and our surprise score is also a residual. And you can see that the abnormal accrual is suffering from some noisy, and this matrix itself is not very clean and it's just full of the noise. So we can see that the prediction result is also not very favorable, and we do not put the results in our paper.
And also I have one other question, because you know the Chinese finance and accounting papers are very popular in the field, and in some of the papers I read that there are differences between the zones or residences in China. And I don't know the places, so I want to put myself aside with the pronunciations, but there are differences even between the financing of the capital expenditures in these zones, or when it comes to the differences between the capital. Did you ever consider this option in your model, any geographical option to your model, for example?
Yeah, this is a very good question. And actually, we have this kind of feature to identify the auditor firm's location. And we also try to identify the auditor's birthplace. We have this kind of features to incorporate in our model to do the prediction. And a very interesting thing is that when we do the feature selection to select which kind of feature is the most important or the predictive to our prediction, we realize that the geographic feature is important. For example, the auditor firm located in the Shanghai or the Beijing can have better audit quality.
Yeah. Meaning in general, when you come up with a large number of variables, you finish up with this problem of some variables being ratio variables, others being categorical variables, and you have to deal with that analytically. And if you have some theories about how to deal with it, you might do a different set of analytics.
Thank you so much.
Is there another question? If anyone have any questions, you can open your mic and ask your question. Matt?
Yes, hi, and thank you so much for this paper. It's really important paper. And may I ask about the mechanism of using the artificial intelligence neural networks? I'm using artificial neural networks to predict earnings management, but I have an issue, and you may have solution, because I think you use artificial neural networks for classified the audit quality, and correct me if I'm wrong. So I know that to train the neural networks, you need real data. Like in your case, for using neural network to classify the audit quality, so you need to know in advance if this, in order to train the network, if this audit is really in good quality or not. So can you please explain how did you train your model? And thank you.
Yes, perhaps I can answer this question, how we train the neural network model. Actually, the basic idea is that we try different algorithms and we actually train different structures of the neural networks. As mentioned before, we start with the simple neural network structure just like the 3 layers we presented in the paper. And actually, we also try some complex algorithms. The way to train the neural network models is just to change different parameters for each layer and to see whether it has better or the more terrible performance on the validation sets. And the way to select the final parameter is to select the combination of the parameters, which can give you the best performance on the validation set. This is a basic idea to train the neural networks. Does this answer your question?
Yes, but I mean, there is always the question because we don't know really, like for me in earning management. So the model give me the answer, like this company have been manipulating their earnings. But the question is that true or not? Always we can't know. You know what I mean?
Can you repeat it?
Yeah, I mean, the model always give me an answer, yes or no. So I didn't understand what technique you used to know if this audit is quality or not.
I have to say that this is you cannot get the best results. You can always get a better results. So this is a comparison process. You choose different algorithms and you define a series of the evaluation matrix you would like to use. In this process, you will select a better algorithm. You have no idea which is the best algorithm. You have to compare. This is the answer.
Okay, thank you so much. I guess
It's a little bit like as good as you can get. You
that's true.
can't invent data. You can't. There is no absolute truth in the world. So you do whatever you can.
There is another question. If anyone have any questions, you can open your mic and ask your question.
Hello. Thank you for the interesting presentation. And my question is just in general, what the manager they can learn from your model, or the companies or firm or the management. So what the benefit or the future suggesting for the company for the the auditing report?
Well, let me try it. This is really trying to create an index for audit quality. And there are many potential clients to understand audit quality, meaning the standard setters, they're definitely interested in audit quality. The audit firms are certainly interested in audit quality, and maybe with less of a motivation, the auditees are interested in audit quality. And you have to kind of take in consideration that audit quality is a fuzzy concept because it's obedience to a set of standards of auditing, a set of standards of financial reporting, which by itself deliver fuzzy results. So the best you can do in these situations is have relative rankings or relative opinions. But the audience are many: standard setters, audit firms, and to a lesser extent, audit clients.
So the learning machine, they can for the helping the management to make decision?
Well, managers, I'm not sure how interested they are in good audits. Okay, managers just want to get rid of the audits because it's getting on the way of their doing their job. Correct me?
Yeah, you're right, because there is internal and external the auditing. And so which one the more considered by the management to helping for to make a decision or the pattern placement of the firm by considering the the quality auditing report. So you understand what I mean?
No.
No, I mean, this is for this model, as you your papers or articles produce it. So there's in the future, if I am, you know, to take this funds to use this model, will help me for making decision for our placement, for our reporting, improve our quality of, you know, our firm.
In the US, the people that choose auditors and worry about good audits are typically board of directors, external directors, typically that are part of the audit committee. And yeah, they'll be interested in finding auditors with high audit quality. And furthermore, the firms might want to be interested to understand how good is the quality of the work they are doing, particularly the large firms. And of course, the standard setters are interested in audit quality.
Oh, thank you.
Thank you very much, dear Professor Miklos and Dr. Sophia and Hanxin, for your contribution and your efforts. Thank you very much. Thank you very much. Thank you very much.
Thank you very much for having us, and have a good day and be careful these days.
Thank you very much.
Nice talking to you. Bye.
Bye.
Nice to meet you.
Bye.
Thank you very much. I hope to see you soon in Egypt.
We hope so too.
You are very, very welcome.
Bye.
See you.